Allie, do you want to shut that front light off so you guys can see better? What's the average rate of change over the interval from 0 to 4 of x squared plus 5x plus 6? What would you do? Find the first derivative. Well, no, you wouldn't find the first derivative. You'd plug it in. Plug in f of 0, and you get 0 plus 5 plus 6, 0 plus 0 plus 6, which is 6. Plug in f of 4, you'd get 16 plus 20, which is 36, plus 6, which is 42, correct? And the average rate of change is the slope. 42 minus 6 over 4 minus 0 is 36 over 4, which is 9 is the average rate of change. Okay? Instantaneous rate of change. Now you. What's the instantaneous rate of change at x equals 4 for that function? First derivative. 3x squared plus minus 6x plus 5. I caught my mistake. All right. So if you stick in a 4 for that, it's 3 times 4 squared minus 6 times 4 plus 5. 48, right? Minus 24 plus 5, which is 29. We good?
Go back to the last one. What was the wording there?
It was the average rate of change versus the instantaneous rate of change. Okay, you got to know the difference between those
They
two.
only give you like 1 point. Is it? You do the...
No, it's average rate of change versus instantaneous rate of change.
So, Mr. Fishbach, in the first one, you can use the first derivative.
No, do not use the first derivative on the first one, because first derivative is instantaneous rate of change at a specific point. This is over an interval, so it's the average rate of change. So no first derivative, it's just finding slope.
Okay.
The second one,
Is that a point?
no, over the interval from 0 to 4.
So that's not saying y and x.
That's not y and x, that's not an ordered pair, that's brackets. Okay. All right. How do you find the average rate of change from -2 to 2 for the following values? It's in a table, Ali Vacanti. You are slaying this. So this would be -2, -5, -1, -1, 0, 4, 1, 8, 2, 12. And then which ones do you look at? Because it's average rate of change. -2 and 2. So it'd be 12 minus a -5 over 2 minus a -2, which would be 17 over 4. Boom, boom, boom. Average rate of change. So did I have to make a table?
Yeah.
No.
Pretty much.
No. You could have just gone straight here and here at the start. But if the information is given to you in a table format, yeah, you just use two ends. Is a function continuous and differentiable at x equals 1? You will have several of these on the test. I only gave you one example, but you will see piecewise functions several times, yes.
What did you just call it?
Piecewise functions, when you have two different things, and there's a break.
I know. And it showed us. Yeah.
All right. So this thing is going like this till you get to 1, and at 4x minus 1, then it goes like this. Though actually like this. Okay? So what you should do is grab your graphing calculator like all of you do. I had my graphing calculator up, I thought. Yes. X squared plus 2x.
The ref, they should have called it. Woody was trying to break through 3 guys, and he finished him into the ground.
Yeah, like how you like calls for the trainer, how he just got.
No, it's because I felt bad.
You know that first punt that we recovered the muff? That should have been a dead ball repunt. Because the whistle blew before the end of the play, before he even received the. It's not your fault. The referees made the decision, which was not officially correct, but correct for that situation. Because it should have been our ball, because the guy muffed the punt and we got on it, and it should have been our ball. But because that whistle was early, it should have actually been an inadvertent whistle, repunt. Replay the down. I am a ref.
Yeah, they did it wrong. You know that? I said if a moonshot, I didn't get catch it.
Yeah. Okay, so back to this. We're going to zoom in. Hey, quit it. We're going to zoom in right on this point here. And, ooh, that looks really smooth. Trace at 1. At 1, we're there. Yeah, I think that's so smooth. It is both continuous and differentiable there. Because it's a smooth curve. Because if it goes like this and then off like this, it's not.
Do the one where like it doesn't. You know how like it makes a point. Like if you do one and then it goes over the other, but it's not like smooth. It just makes a point.
That's what I just did right here. Okay, so it's like this and it's like this.
Yeah, you see how that makes a point, Alex?
So then that's not.
That's what I see all the time.
What if it crosses that twice? Does that make a difference?
No, but it has to be where this point is.
So that's right there.
This one is this one, because it's smooth when it transfers, it is both continuous and differentiable. What? Yes, you can. Anna said, can't you just calculate it? And the answer is yes, you can. What's the first derivative of this? At 1, you get. What's the first derivative of this? They're the same. From both sides. From both sides, it's the same. Okay?
What? I thought you just plugged in that one for that.
You have to plug in the 1 first to figure out if it's continuous. And if you take the first derivative from both sides, then it's. Yeah, if it's the same derivative from both sides, it's differentiable. Because some of our graphs are complicated, and I thought it's just easier to look at the graph.
No, it's easier to look at that. If I know
Okay.
they're the same number, I don't know.
Okay, well, whatever. You guys do it Anna's way, because that's actually the better way of doing it.
You know what? I'm gonna do it that way.
Okay. What's the value of the function? Or here's a function here. At f of 2, what's the first derivative of f of 2? What's the first derivative of f of 2? So we're looking at the red function. We want its first derivative. So then what I did is I graphed the tangent line. So what's the first derivative at 2? 2. Why? No. No. The answer is 2. Why is it 2? Come on. You guys are smart.
Wait, is the slope of the tangent
That's the slope of the tangent line. The first derivative is the slope of the tangent line.
How'd you make that tangent line?
I said, well,
You already knew the answer.
yeah, I kind of, because to be honest, I took the graph 0, 0, 1, 1, 2, 4, and I know the slope at 1, 1 is 2 because the first derivative of x squared is 2x. And then I just translated the graph 1 over and 1 down, but that would not change the derivative.
We got like 2 numbers up there. I don't even know what we're getting.
Dude, your test is gonna.
Basically, he took
Is
the
there gonna be a
graph,
graph like that on the
transferred
test?
it
Yeah,
Like
But it's
exactly
still
like
the
mine?
same.
with a tangent line.
Okay, with the tangent.
It'll have the tangent line graph. So what do, Nate Ricky?
You find the slope of it,
Of what?
the tangent line.
There you go. See, when you're paying so much attention to your computer, I don't know if you're listening.
Slope at 2?
I'm just trying to.
No, yeah, the slope when x equals 2. When we have an x value of 2, what is the slope of the tangent line? Yes, it is 2. Because you go rise up 2, run to the right 1.
So if it was
The tangent line is a straight line, so its slope will always be the same.
So it doesn't matter that it hits 2, that literally is
so what if it was
Well, it does.
Bitch,
Literally, it does matter, but in your brain, no, it won't matter. Yes,
F of 3, would it
f of 3 would have a different tangent line. Its tangent line would look like this. Not vertical,
That
but
slope looks like it's about 4.
so would it be 3?
And it looks like
That's
no. Over here,
That's another guess.
it would be 6.
Do another example of that.
But are the slopes like real numbers or like strange?
They're integers. They'll be integers or rational numbers, so normal numbers.
So you could actually see it.
You should be able to see it and calculate it, yes.
Don't say anything. I got this.
You got this, Olivia.
Oh, that's what I got.
Yeah, so that's like 10. Get back.
Oh, yeah.
So this is at 1.
Up to, it's 2.
Yeah.
Isn't it negative? But the slope is
negative.
still 1. Yeah, it's negative. No, the slope is
What's the slope of the tangent line?
negative. Just 2.
Negative almost 2.
What?
Negative 3 over 2.
We go from this point to this point, we can calculate the slope.
Oh, so you're basically finding the point on the y-axis and x-axis where they cross, right?
And find the slope.
Okay.
So how do you do the first one then? I don't.
Up 2 over 1.
And there's not a point.
You know what? I got it, Mr. Richard. I gotcha. Next problem.
What's the equation of the tangent line at x equals 2 for this function?
Oh, this is when you make the y.
Oh, wait. This
Is that y
What's
minus
slope
y2
form?
is
You gotta do the derivative though.
Do the derivative.
Do the derivative of 11.
The first derivative at 2 is?
yeah.
That's the slope.
Slope.
That's the slope.
Oh, I said it.
That's a slope. You find f of 2, which is 3 times 2, 3, okay, 3
Minus 33 plus 4.
minus 22.
Oh, it's a 2.
So it's 12 minus 22, which is negative 10, plus 4, which is negative 6, right? So our point is 2, negative 6.
So y plus 6.
Y plus 6 equals 1 times x minus 2. So y plus 6 equals x minus 2. Y equals x minus 8. The equation of the tangent line. What?
You always do this. You always do minus 6, but it's actually negative. So if it would be a negative 2x, it would be plus 2.
Right. On this graph, which one has the greatest value? F of A, F of B, F of C? The first derivative at A, the first derivative at B, or the first derivative at C? Yes, we have. Very minimally, but yes, we have.
What's the first derivative of A?
First derivative of A, I would say, is probably 0.
So what's the first derivative of B?
I don't know. But now think about this. Use your brains.
I literally don't.
Yep. Quit chapping you. Let's use our brains. Okay. What is a derivative? It is the what? Slope of the curve. So the first derivative at A, what's a y value at A? It's like -2, right? What's the y value at B? Like -1. What's the y value at C? Like 0.7. What's the first derivative at A? It's a horizontal tangent line when it hits it. That's 0. What about this one or this one? The first derivative at C would have the greatest value because the slope would be like 10 or 12 or something like that. Okay, versus a slope of like 1 or a slope of 0. And it has a bigger value than any of those points. No, it's not always going to be a derivative.
Yeah, Olivia.
But Mr. Bierschbach, if that would be negative.
If it would be negative, a negative slope is smaller, so then like the value at C would be the highest. Okay, so Anna, let's do this. Boom, boom, boom. A, B, C. Okay, F of A, F of B, F of C. First derivative at A, first derivative at B, first derivative at C. So, F of A is like 2, right? Where F of B is like 1, F of C is like -1/2, right? Just in general. Okay? What's the first derivative at A? 0. What's first derivative at B? Like something negative, like -1. First derivative at C is like -5. What would be the greatest? A. Okay? See, Olivia? It's not always a derivative as an answer. Okay. Okay. An approximation. Now, some of you might get mad at this problem because there are some fairly close answers, but there is one correct answer on the test. Trey Smith. No. Thank you that it's a joke, because no. Okay, what's the answer? How would we find the answer? Okay, so what's going to be our y2, Allie? No.
19.
Oh. Man, that is tough.
And then 18.9. Wait, what? Yes.
Yep.
Yeah.
Yep. I agree.
I also am following.
4.2.
Allie's using the points that she wanted to use, but
When you use the 4.2,
No, you wouldn't use 4.2 because 4.6 is closer to 4.5.
yeah, they're really close to each other, so that slope's going to be really close right there. Yeah. Because it's going to be really close to this. Now, if you use the other points, because it's going to get skewed because we're so far away from 4.5 here. If we use 4.6 and 4.2 and 19.9, 19.9, 18.9, 4.6, 4.2 is 1 over 0.4. What's 1 divided by 0.4? I think it's 2.5.
But I can still make that approximation.
Which, the right answer on the test might be 2.9. Well, you can see that those work. This one is a little bit of a skewed answer. Okay. Where is that function decreasing? What would you do?
Oh my
Take the first derivative.
You could. We haven't learned that stuff yet, where you take the first derivative and then look at the slope and figure out where the slope is negative. But we haven't looked at that yet. That's upcoming yet. So what should you do with what our current knowledge is? No.
Dude, I have no idea.
We have never had a question
Graph
like
it,
that.
Yeah, graph it on your graphing calculator. Figure out where it's decreasing. Remember, this is a multiple choice test. So you look at you graph it on your graphing calculator, then look at the answers of the multiple choice test and figure out which intervals it's decreasing.
Oh, it's gotta be like 1.
Okay, now I just slapped up a willy-nilly equation here. So it doesn't have very good values to it for where it's decreasing. But if we go 3x cubed minus 2x squared plus 5x minus 4 graph. And I'm too zoomed in here. Zoom 6. Ooh, this is bad. Okay, let's just say it goes like this. Where is it decreasing? Well, it's decreasing from here to here. Okay? And we got to find where it's decreasing. The one on the test is easier when you graph it. No, you don't have to. Well, no, you can. I'm just asking, where is this decreasing?
Is that in the brackets though? Right?
From like -4 to 6.
Wouldn't it? Yeah, like that.
Okay.
Why?
And actually, you should have parentheses, not brackets, because right here it's not decreasing or increasing, its slope is 0. Okay, find the first derivative of this function.
It's just x.
1x to the
-1/3.
-1/3 minus, come on, it can be more than just Olivia,
0.1.
1 over 10 x to the -4/5
-8
plus 8
to the -3rd.
Nice.
So on the test, it'll probably be written like this.
Oh, I got that part. I don't know how you did the last one.
The last one?
Because this is -4x to the -2nd. Okay. What's the first derivative of the ln of x over x?
1 over x over x. No.
1 over x squared.
X squared times 1 over x.
It's x
X
times the first derivative of 1 over x.
1 over x.
First derivative of the ln of x, I meant. Plus, minus the ln of x times 1 over
X squared.
x squared,
Yep.
Where are we getting?
which is 1 minus the ln of x over x squared.
Oh.
The quotient rule. It's a
I'm
fraction.
feeling that. I feel it.
No, you're
Okay.
No, I get it. I get it now. Actually.
What's the first derivative at pi over 6 of the cosine of x?
Oh, we got that one.
Yeah, that one's easy.
Yeah, move on. I don't want to get the graph circle out.
Okay, so it's negative sine of x is the first derivative, right? So it's negative times the sine of pi over 6, which is negative 1/2.
I can do that. Hey, are we gonna get those?
Yes.
The derivatives of the
Yeah, I'll give them to you this time.
Yeah, but you said we're gonna get a notebook. So
Did
we
I
can
say-
put all that stuff on.
Yeah,
Oh.
I
Next
did say
time.
that.
But this time we get to use our notebook. I'm not
No.
gonna cheat.
No, you're not going to use your notebook. I'll write everything on the board.
That's fine.
Okay, what's the first derivative of 0 of all this stuff?
Change the first derivative and then plug in zero.
First derivative at 0 of all that stuff. So first of all, what do I do?
Negative
Four
4
sine
sine
of
of
x
x plus 3x plus minus
What the?
minus
X.
2x EGM.
Whoa, 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 whoa.
Yeah, that's what I was saying. No.
This is the
Oh, you gotta multiply things.
product rule. So we got to go boom, 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 boom. Product rule.
Negative. Oh.
Because it was minus, so I go plus a negative. So it's going to be the first times the first derivative of the second plus the second times the first derivative of the first. Yes, Alex, it will. I just want to make sure everybody knows what's going on first. And then we plug in the 0. What's the sign of 0?
That was a shot in the dark.
Zero.
The sign at 0 is 0. What's e to the 0? What's 0 squared? What's 2 times 0?
So 3. I said 40 though.
What is the first derivative of that
Oh, this is
function?
the quotient one.
Yeah,
We're gonna quotient that one.
Minus 5 times 2x plus 2
minus x
One.
squared
oh,
plus
squared plus
2x minus 3 times 1.
Nice, that one.
x minus 5.
And then x minus 5 squared.
Now, it is a multiple choice test. So they will have the simplified answer of this.
Bruh.
2x squared. Outers is plus 2x. Inners is minus 10x, so minus 8x. Minus 10. Minus that quantity, which is minus x squared minus 2x plus 3 over x minus 5 squared. So it's x squared minus 10x minus 7 over x minus 5 quantity squared.
You don't square it on the bottom.
You don't have to multiply it out. No, I think they'll leave it in that form. Okay, what's the first derivative of sine of x cotangent of x?
Not
No, negative sine.
It's negative sine
Cos.
squared plus cotangent squared.
It's it is,
I know what cotangent is.
what is the first derivative of cotangent?
It's like negative cosecant.
Negative cosecant
Yeah.
Yeah.
squared of x, right?
Yep.
Plus
Plus.
cosine of x times cotangent of x. Now, what is cosecant squared?
Are you doing that because of the product?
Yes, this is a product
Just
rule.
making sure, gosh.
1 over sine
That's so hostile.
squared.
Somebody's phone hit the floor.
Take it. Take it,
1 over
please.
sine.
So it's cosine squared.
Negative sine squared. The sine. No, 1 over sine.
1 over sine
Plus
Cosine
cosine squared.
squared over sine.
And I don't know how far they'll go, but you could keep going on this.
I know you can.
1 plus cosine
That looks like a.
Way far enough.
That looks like the
That's
tangent
nice.
form, isn't it?
squared. Wait, that's sine squared over. Yeah. So it's sine over negative sine. It's just sine.
Holy smokes.
I can do way
Oh
too
my
much.
God.
I couldn't get the words out. I had it in my head.
Now, why is that? Well, what's sine times cotangent? Whoop. What's sine times cotangent? Well, it's sine of x times cosine of x over sine of x. Sines cancel. So what's the first derivative of the cosine of x? Well, it is negative sine of x. I don't know. Depends on if they stop right here on the test for the answer or if they go all the way here.
Just see the multiple choices.
It is multiple choice. So 33 multiple choice questions to challenge you. Maybe I'll, over the weekend, if I get frisky, I'll add a couple more questions, make it 35 questions. So we'll see. This is the AP. That's why we